Okay, this is the third video that goes with the triangle foldable that looks like this. So we have a couple videos already loaded. Now here's the last video. So if you're looking for anything in the middle, obviously go to one of the other videos. So we have medians is the next thing. So a median is a segment that joins a vertex to the midpoint of the opposite side. So it's going to go from the vertex straight to the middle of the opposite side. So that means that this piece is congruent to this piece on this side because this D is a midpoint. So a median would be this line that's drawn right here. That's going to be a median. Now that's unlike the last thing because we had angle bisectors and that divided an angle. So it didn't necessarily go to the median of the middle of this other side. And then we also had some perpendicular bisectors. Remember, those were perpendicular, so they did hit the median, the midpoint of this side, except they didn't necessarily go to the vertex on the other side. So sometimes it will be the same line depending on, like, if you have a perfect equilateral triangle. Sometimes a lot of these are the same thing, but if you have any funky shaped triangle that's not perfect, you gotta just follow the directions. So we could make medians for all three of the sides. So you could make a median for this side. So we could join this vertex to the midpoint of this opposite side. So the midpoint looks like it's about right there. So this would be another median. And we could even draw the third one. Now the place where all three of those would cross is called a centroid. And like I said, I'm not sure if they'll use that vocabulary ever on your OST, but just know he does have a name where all three of them would cross. So let's use this information about medians. So if we look at this, it says segment TQ is a median. So if something is a median, then what do we know is true? If it's a median, it goes from a vertex and hits the midpoint of the opposite side. So this right here is a midpoint, right? Now, what do we know about midpoints? We know that it cuts a segment into two equal pieces, right? It's like it bisects it. So that means that this piece is the same length as this piece because that's a midpoint because of median. So if we want to find TR, so TR is this piece right here. If PR is 4. So it's telling us PR. So that means from here all the way to here is 4. So if that's true, how long is it from T to R only? So of course, since these have to be equal and they have to add up to be 4, then the answer is going to be 2. This piece is 2 and that piece is 2. So the measure of TR is equal to 2. Now remember, when we don't put any bar on top of here, we read this, the measure of, or length of TR is 2 units long. Okay, we also have altitudes. Now altitudes are segments from a vertex that is perpendicular to the opposite side. So that means you're going from a vertex, like, I should pick a new color, this color. I'm going from the vertex, and I have to go straight to the other side so that it hits perpendicularly. And that one's nice and pretty. Now this one's okay too. Vertex, it hits this side at 90 degrees. Now what's going to happen if I go from this vertex? Do you see how I'm going to end up outside the triangle? Because there's no way I can get over to this side. Because watch, if I start to draw things over here, is there any way it's going to be 90 degrees over here? Absolutely not. So it's going to have to drop down, and that's going to put me outside of the triangle. So this is one of the weird ones where altitudes are allowed to actually be outside of the triangle. And this one is actually right on one of the sides of the triangle, because if I started at this vertex up here that's green, the only way I'm going to hit this bottom side down here is if I drop it straight down. And so he happens to be right on the side of this triangle. So altitudes can be right on the triangle, like inside the triangle, outside the triangle, right down the middle of the triangle. So let's see what we have here. This is an always, sometimes, or never. Provide proof. Okay, it says an altitude is, we got to fill in always, sometimes, or never. An altitude is always, sometimes, or never the same line segment as the angle bisector. So an angle bisector, remember, cut an angle in half. So let's look at these pictures because we actually have 4 examples of different triangles right here. So this one here, this green line, if I were to draw an angle bisector, let's draw an angle bisector in a different color. I'm going to draw an angle bisector in purple. So I'm going to make my angle bisectors. If I were to draw an angle bisector from here, that would mean it would have to cut this angle in half to make 2 equal angles up here. So it probably looks something like that. Is this green line and this purple line the same line? No. What about this one? If I were to make an angle bisector of this up here, I would have to cut this angle exactly in half. It might look like that. Does that look the same opening as that? Once again, the purple and the green line are not in the same spot. So this is a no. So far it's a never, right? What about this one? If I were to cut this top angle in half, I'd have to come right here to get this angle to equal this angle. Is that purple one on top of the green one? Nope. What about this? If I were to cut this here and cut this top angle in half, boom, boom. Do you see how they land on top of each other? So this is a yes. So it looks like, does it always? Are these lines the same always? The purple and green lines? No. Is it sometimes? Yep, sometimes. It's not never because it happened right here. So it looks like it's going to happen. It will happen when you probably have maybe an isosceles triangle, some triangle that looks even on both sides. And then you're going to be able to match. And the last one we have is some mid-segments. So a mid-segment here have some special things. So a mid-segment joins the midpoints of 2 sides and is parallel to the third. So I know this picture looks like a hot mess, but really this is what we're talking about. If I have a triangle like this, pretend like this is my triangle. If I wanted to have a mid-segment of, I'm going to go from this side right here. So what I would have to do is find the middle of both of my other sides. So I would say the middle of that side is about there, and the middle of this side is about there. If I were to connect these, if I join them, they're going to be parallel to the third side in half the length. So these are going to automatically be parallel. And one of them is going to be half the length of the other, which means if this one was 8 feet long, this one is going to be 4 feet long. So that's going to be true about all mid-segments. So if you cut it at the midpoint and connect it, it's going to make one that's, and you could do them any way you want. So if I had, say, this triangle, if I did it to this side down here, that means I needed the midpoint of this piece. I need the middle of that piece. If I connect them, I'm going to end up with a parallel line. And if I knew the length of this was, say, 10, then I would know the length of this one would be 5. So that's all that's saying. Now this one has drawn all 3 of them in the same picture. So that's why it looks a little bit confusing. I wanted to separate and draw you a couple of them just plain. So let's take a look at this. It says if M, N, and P are midpoints, mark the parallel sides. So I'm going to do them in color. So that means that this side is going to be parallel to this, right? And what else we got? This side is going to be parallel to this. Should I try to put little baby arrows on all of these? Double arrows there. And then we have the last one is this one and this one. So that would need like 3 arrows and 3 arrows. So we have all the parallel sides. Look at this picture here. So we have an example. Now they don't come out and tell you it's a mid-segment, but isn't S a midpoint of this? Because I got these 2 double things. And isn't R a midpoint of this? Because I got these matching ticks. So we do have some midpoints, which means that this blue side right here is going to be parallel to this side, correct? And also, it's going to be, this one is going to be half the length of this one. So if you see here, this says 5 right there. So if I wanted to know the length of IK, which is what they're asking for, it's got to be twice as long. So that's going to be 10. So the answer is going to be 10 units long. Remember, this should be glued into your notebook, and you have a practice paper that matches all of these. Remember, you could play any of the 3 videos back if you need to review on them.